us how you could start using SQL to process streaming data. And we've got this product called Agile Data, and we have a booth right over here behind you with a guy in a very nice, amazing jacket walking up from that booth named John. So if you have any questions, you can either talk to John or me about that. But what I basically want to talk about is how we at Agile Data deal with the idea of streaming data and how we approach it with SQL. You know, we think that Agile Data is the simplest way for, we say enterprises, but companies of almost any size, to leverage big data without having to become experts in the crazy landscape of big data tools. You know, as you guys know, my slide deck just crashed. As you just noticed, my slide deck just crashed. That's amazing. Have you ever had like Keynote just crash on you? Let's try again. It didn't crash. Okay, good. So big data is this very powerful set of technologies and practices that we have kind of taken the world by storm, in the sense that you are dealing with so much more data than you can fit on one machine or that you can fit into one relational database. And so now there's this whole slew of technologies that are out there to deal with that. And businesses are getting huge value out of it. And this mic is very hot. Businesses are getting huge value out of it, the ability to use tools that scan data massively in parallel across a huge cluster of commodity machines in most cases. The problem is that in order to manage all this, the tooling, is it crashing again on me? The tooling can get pretty complex. Every year there's a new deck that comes out that just summarizes the size and the scope of the big data landscape. If you guys have been looking at big data technologies, you've probably seen this big data landscape thing show up. And it's very hard to get started. If you're looking at Hadoop ecosystem, if you're looking at a streaming processing ecosystem, it can be pretty daunting to try to figure out, how do I get started with this? How do I use this in my company? And what we wanted to do is make that a lot simpler, at least to get started for simple problems that you want just a solution for a small piece of value to add to your business without retrofitting your entire organization and sticking a whole new set of functionality and replacing a whole bunch of databases. So what we want to do is offer something that you could just do value add and then transition into a much more complicated Hadoop-based possibly situation, but on your own terms without having to go in and forklift everything, right? So what we basically did is we put together a set of 4 principles for us which outline how we would like to help you do better with big data. And we view that should be simple. You should be able to understand the system that you're building. It should be available to everybody that touches that data. The DBAs that touch the data shouldn't have to learn a whole bunch of new programming languages like Clojure or Scala, even though they're fantastic languages. The ops people should be able to understand what's running and when it crashes, when machines go down, what happens to those machines, why did they crash. The developers need to understand how to get their code into a running cluster of machines so you can actually do streaming processing in an easy to maintain way. So simplicity is incredibly important. The scalability comes without saying. You have to be able to scale beyond one machine. You have to be able to add more machines as the data volume grows. You have to be able to stream data, which basically means react to data in the order that it appears. As it hits your company, you want to be able to react to that data in almost real time, or as close to real time as your business case needs. That could mean seconds, it could mean minutes, but it certainly doesn't mean days or hours. This mic is very hot. I almost think I should switch mics on you guys. I think I might. Let's see what happens. Yeah, I got a mute on it too. Or you could just turn it down. All right, they're turning it down. We're good. And you want to be able to do all this streaming with SQL. Like SQL is the lingua franca of data management and has been for well over 20 years. There's different flavors of SQL. There's different database providers that let you work with SQL, but it's intuitive. I can show you SQL and you can kind of read it and have a decent chance of knowing, how does this work? what problem is this solving? It's accessible to an incredibly wide range of talent that's already in your company. It minimizes the training costs. You don't have to hire expensive new consultants. If you can express a computation in SQL, it's tremendously valuable. So what can you do? What kind of use cases would you be able to apply these principles to? The one that we found a whole lot of success in is the gaming use case, which is mobile games, anything that involves users or a user community, networking communities where you're trying to rank things. This example here is a Clash of Clans example where you have the top users scored by points. Well, you want to keep that up to date in real time. Every time you do anything, the user they expect that their rank will change. Of course, every other user is also doing the same thing. And so you have this kind of centralized dashboard that you need to put together to show to everybody that has inputs from every single user doing different things. And in a large game, that can rapidly get up to hundreds of thousands to millions of events per second just hitting that game server. If you want to keep an aggregate dashboard up to date that has low latency, and we're talking not 10 minutes later, but we're talking, the user did something in less than a couple seconds, it's up to date, you need something that can react to that via streaming. And the way we do that is we model the data inbound, all those user activities, as a sequence of tuples that you can process. It's data you can process using SQL to store a cached copy of like this kind of a dashboard for people. Another use case that we found is very useful is a totally different industry, and that's the industry of catastrophe modeling for insurance companies. Well, primer on insurance, if your insurance company insures your house or your car or something, they can use actuarial methods to determine whether or not they should cover your house and what their financial exposure is in the event that your house burns down. Because not all houses burn down all the time. But when a hurricane comes in or an earthquake occurs, that can hit an entire huge swath of somebody's portfolio, an insurance company's portfolio. Well, what happens then is they could go out of business if they don't have enough money left in the bank, right? And that's the reserve requirement, and you hear like the too big to fail thing with AIG, and you hear all sorts of excitement around that. Well, if you want to model that, and I have a calendar invite interrupting my slide presentation. That's cool. If you want to model that and figure out, well, what's the probability that some hurricane is going to come in and wipe out my portfolio? When Hurricane Andrew hit, it put 38 insurance companies out of business in 1992, right? Because they weren't paying attention to this. And so there's massive value for insurance companies to simulate what are all the potential catastrophes that could hit, and how do I react to that? What does that affect an insurance portfolio, which is a crazy big data problem because it gets really complicated. But in order to do that, you have to be able to at least pipeline your jobs. The real-time component isn't as strong here, but you don't want to do this batch job and then this other batch job and then another batch job that consumes that and yet another batch job, because every time you do that, you got to write to disk. And it's slow, and it takes hours or days in some cases. So in order to do this, you want to pipeline that data. We find that's very helpful for these types of large-scale analysis operations where you're not just dumping the output of a batch job into something else, but you've actually structured it as a streaming computation so you can pipe the data all the way through. The simple example of this, if you were here yesterday, you saw this slide, which is, this expresses the idea of streaming SQL as cleanly as we possibly can, that it just shows you some of what the power is here. This imagines that there's a stream of orders, users buying things, people buying stuff. And all we want to do is figure out what's the name of the user. In this case, the order stream does not have the user's name in it. It just has the user ID, which is useful for some things, but if you wanted to present that or send an email or do something as soon as that happened, that's an opportunity for you to join that event onto the users table, the customers table in this case. If you do that, in a regular application, you might pull it off of a message queue, and then you have that, you say, oh, I need to go fetch the user ID. You open up a connection to your database, and you pull that information out of the database using a regular select statement. But if you pay that network cost over and over again when you do that, because each time you have to issue a new select statement, it has to be parsed again, it has to be planned by the query planner in the database. And if you do that for a fast enough stream, it's actually pretty slow. It won't work for you. But what will work for you is continuously joining with a hot cache of that data. And why build that when you could just write it in SQL? It's kind of our argument. And so we hired a bunch of really smart people to figure out the hard stuff underneath the covers, so you can express this kind of streaming join that's always got the user data attached to it for future consumption. So if you need to send an email, a thank you email to that user that says, hey, thanks for sending this, here's the way to join the data all in one shot. I wanted to talk a little bit about kind of how we do that. You know, I talked a little bit about logs yesterday. The way we do this is we track the actual actions that occur to the database in that log. We say that it's not like application logging. It's not the user clicked this. It's actual data that you write to disk first in case the machine crashes, so you can always replay it. And those logs themselves are streams. The messages on the streams, the pieces of data on the stream are little bits, like a little bit of an insert statement into the employee record or a mutation updating of employee record. And you can replay those and reproduce the same state at any point. And if you use logs, it allows you to treat a log as a stream in and as a stream out. And the same thing that it writes very efficiently to disk, you can write to a network for another machine to take advantage of. And in the middle of all this, you're applying your streaming processing. This is where user-defined functions that you could write in Java or SQL or .NET or C++, you can apply to that data in motion while it's flying through. And our system can take advantage of the fact that you use SQL and do intelligent query planning to make sure that we're running it on the right nodes. This is all within one node within an Agile Data cluster. And we chain them together in a fairly simple manner, keep track of who's in charge using Apache Zookeeper, if you've ever heard of that. And we pair local storage, write-ahead logs, and stream processing in each node to make sure that you can express a computation on a global cluster of servers in the most efficient manner. So our query planner has to do some really neat stuff. Going into how this log stuff works between brokers, we actually take each partition of the data you put. When I mean partition, I mean if you have so much data that you can't put it all on one machine, you have to put it on more than one machine, how do you split it up? Do you take just half of it, or do you take an ID and compute a number? Because if I only have two partitions, I've got partition 0 and I've got partition 1, which one do I choose? Usually you do that with a function called a modulus function in some cases. There's a bunch of other interesting functions, but we do it like this. We allow you to have a specialized partitioner function. In this case, it's a view. It's an actual database table that we manage for you and store in our cluster for you to query. We can feed that off the replication log of your relational database and allow you to do things, but we'll split it up across the cluster. In this case, there's only 2 partitions in this whole thing, but if there were 1,000, I would rather not put 1,000 boxes on here. But it'll take a little bit of math and sort out how to put this here. And once you've expressed the partitioning via SQL, now you can do really powerful things. You can also partition streams. So you can do processing spread out across a cluster as well against each partition. In this case, I've got a click stream that really doesn't have any inherent partitioning. It just has data, right? It has data about who clicked it, what time did they click it, what did they click, maybe a URL. And this is a user-defined function that maybe pulls off of a message queue you already have or tails your server logs. And we have a very simple API for you to implement a user-defined function that sources this data in whatever language you have very easily. So by searching that, you can execute this computation across as many nodes as you need to, right? Using that kind of continuous stream function. You could do that from a view as well. So the cool thing is you could do it from continuous data that we've sourced off of a message queue or somewhere, or you could apply the same logic to a view, which is exactly the same as querying a table in any other SQL system. So it should look no different in this case, except that we called it a view. It's just a distributed table, and we handle running it across that cluster. If one client wanted one answer to say, give me everything from here, our system takes care of the fact that you need to run that on 2 machines and then merge the results to give it to the client. So if you wanted, in this example, all the data in this view, that's probably not a very smart query to run, but it would funnel all to that client. We will merge the data. We'll handle routing the data from the multiple nodes to the node that you want. And by doing that, you're able to get local execution next to that view. So anything you could fit in a select statement, like computing other functions, transformational things, counting, aggregation, all that sort of stuff runs right next to the data. And the way you send that to the cluster to run is the application that's connected, or the client just sends the SQL, and the cluster figures out how to run it. I'm running out of time, so I want to hurry. It allows you to do streaming joins. So you can join that stream of clicks against that view of users, identify those clicks, and you can do this on a continuous basis if you're dealing with a click stream. Right? And it's very simple in this case. It's, again, just SQL. You have the click stream here. You're joining the users on clicks. And the partitioning, in this case, just inherits the partitioning of the click stream. And because it's compatible with the user's view, there's no data that has to shuffle. It's all in the right place. So in the very little bit of time we have left, this slide I had up yesterday, it basically explains how do we approach big data processing within Agile Data. And what we do is we basically provide a clustered database processing solution that allows you to store data and process it, that plays nice with whatever database you might already have, plays nice with message queues or any other kind of event stream, to use that either as sources or sinks for that data, and then allow other applications to query that data in an interactive fashion, as if you had just one server that was a database server, but in reality it's a cluster, an intelligent cluster that's figuring out where to run your query. In order to do that, we had to write a lot of really cool stuff, and I'm really proud of what we have, and it's a very cool product. We've got a booth over here that I'd like to talk to you more about if you have any questions. John and I are sitting in the corner, and we'd love to talk. But even if you don't use Agile Data, I think it's important to think about these 4 principles, right? When you build big data solutions, favor simplicity. Don't just add another piece of technology because it's cool. Really make sure it matches your use case. Stay simple with your data. Make sure that whatever you use actually scales out cleanly and manageably. Prefer streaming if you can. And if SQL is an option, as it is with Agile Data, you should use SQL, because you're going to enable a huge portion of your enterprise to be productive without having to learn some crazy new technology, as amazing as it may be, right? So again, our booth is literally right over there behind you. So I'd love to talk with you afterwards. I want to make sure I end on time, and I'm 15 seconds late. So thanks, guys.